So let's just talk about some of the important terminology in tree data structure. So first of all, let's just talk about the root. So root is the topmost node in a tree which has no parent. So like an example here in the tree, this node 1 is the topmost node and it does not have any parent. So that's why this node will be the root node. So in a tree data structure, all the nodes will fall under this root node. And next we have the parent. So a parent node is a node that has one or more child nodes. So like an example, this node has the child node 2 and 3. That means we can call this a parent node. Similarly, the node 2 has two child nodes 4 and 5. That means also the node 2 can be called as a parent node. So next we have the child node. So a node that is directly connected below a parent node is a child node. Like an example here, 2 and 3, they are directly connected to the node 1. That means we can call them child node. Similarly, the node 4 and 5 connected directly to that parent node 2. So these nodes can be called as the child nodes. And next we have the siblings. So siblings are the nodes that share the same parent. So like an example, the node 2 and 3, so they share the same parent node which is 1. So that means they can be the sibling. Similarly, the node 4 and 5, they also have the same parent too. That means they also can be called as siblings. And also the node 6 and 7, they also have the same parent. That means also we can call these nodes as the sibling nodes. And next we have the leaf node. So a leaf node is a node with no children. Like an example, we have the node 4, the node 6, 7 and 3. So these nodes, they do not have any child nodes. Because of this, we're gonna call them the leaf nodes. So leaf nodes are the end point of all the branches of a tree. So next we have the ancestor and the descendant. So ancestor is a node that is above a given node in the hierarchy. On the other hand, descendant is any node that is below a given node in a hierarchy. Like an example, we can take these two nodes 1 and 2. So this node 1 is above the given node 2 in this parent-child hierarchy. That means we can call the node 1 as the ancestor. Here, because the node 2 is below this node 1 in this hierarchy, that means we can call this as the descendant. That means the node 2 will be the descendant of the node 1, and the node 1 will be ancestor of this node 2. And next we have the degree. So degree is the number of direct child a node has. Like an example, so here the node 1 has 2 direct child. That means the degree of this node 1 will be 2. Similarly, this node 2 has 2 direct child. That means the degree of the node 2 will also be 2. And next we have the depth of a node. So depth is the number of edges from the root to that particular node. Like an example, suppose we are looking for the depth of this node 4. That means we are going to count the number of edges from the root node to that node. So from the root node to that node, we have 2 edges. This is the first edge and this is the second edge. So that means the depth of this node 4 will be 2. And here in case of the number 7, here we have 1, 2 and 3 edges from the root node. That means here the depth will be 3. And next we have the height of a node. So height is the number of edges in the longest path from that node to a leaf node. Suppose you are looking for the height of this node 2. That means we have to find the longest path from that node to the leaf node. So from this node 2, we can reach the leaf node 4 and also we can reach the leaf node 7. So in these two paths, the longest one is from 2 to 7. So in this longest path, we have to count the number of edges. So here we have 2 edges. So that means the height of this node 2 will be 2 because the longest path has the 2 edges. And next we have the height of a tree. So this is similar to finding the height of the node, but the difference is that here we have to find the height of the root node. So the height of the root node will be the height of the entire tree. So to find the height of the root node, we have to find the longest path from the root to the leaf node. So from this root node, we can either reach the leaf node 3, the leaf node 4 or the leaf node 6 and 7. So among these paths, the longest one is to the leaf node 6 or 7. So we have found the longest path. Now we have to find the number of edges. So here we have 1, 2 and 3 edges. So that means the height of the entire tree will be 3. So these are all the important terminologies that we should know about the tree data structure. So hope you understand the concept. See you in the next one. Take care.